Hi everybody, welcome to physics class Thermal Properties of Matter. In previous physics period we already discussed about thermal capacity, also specific heat capacity of solid and liquid. So let us go to today's topic. Melting and solidification. What's melting? Melting is the change of state from solid to liquid without a change in temperature. We already discussed this thing when we learned like a heating curve and cooling curve that time. Yeah. So that time when the solid will change to liquid, that means when ice will change to water, the temperature will remains the same. That particular temperature is known as melting point. Okay, it will happen only at a melting point. Okay, so melting is a change of state from solid to liquid without a change in temperature. Melting point means that is the temperature at which the solid will change from solid to liquid. So that particular temperature is known as melting point. So each and every substance have different melting points. Okay. In case of water, the melting point is 0 degree Celsius. During melting, the temperature remains constant. At the melting point, heat is absorbed by the substance. Okay, that means you will get heating curve. You are supplying heat energy. Okay, so the ice will absorb the heat energy and it will start to melt and it will form water. Okay, then what is solidification? Solidification is the reverse process of changing a liquid to a solid. Okay, like a pure substance will freeze at a temperature equal to its melting point. Okay, during solidification, the temperature remains constant at the freezing point. Heat is released by the substance. That means over here liquid to solid. That means the opposite of melting. But the temperatures are constant. Freezing point and melting point. Both are same. Okay. But that's what we are saying, like it will remains constant. Okay, at a constant temperature it will happen. So during solidification the temperature remains constant. At the freezing point heat is released by the substance. So you will get what cooling curve that time. Okay, this is the first thermal physics class that from the school I explained about heating curve and cooling curve. Okay, so that is just revise again. Okay, next one is effect of impurities on the freezing point of water. The presence of impurities always lower the freezing point of water. See, you can like maybe so these things during winter, like in cold countries, the expansion of water on freezing can cause pipes in car cooling system or homes to burst. So to avoid like this problem, in the car cooling system, drivers will add antifreeze to lower the freezing point of water. Okay. So what will happen? If the temperature will goes below 0 degree, the water will not change to ice with the presence of the antifreeze as an impurity. That's what the presence of impurities always lower the freezing point of water. That's what it's not changed to ice below 0 degrees. Then another impurity is salt. Okay, you can put salt on roads during winter to prevent the formation of ice. Okay, so the ice will melt. Okay, and you can avoid the traffic blocks. Okay, And also, this salt is one of the good impurity, but you cannot add this into the car cooling system. Why? There is another, it will not freeze, but another problems will come like a corrosion and like these things. Okay, so it will be dangerous. So we are not doing like that. So we are using in the car cooling system anti-freeze. Okay, but roads and like these icy areas, we are putting salt as an impurity. So the presence of impurities lowers the freezing point of water. Okay. Next one is effect of pressure on the melting point of ice. Okay. The melting point of ice is lowered by an increasing pressure. Okay. How? Take two ice cubes and press together. When you press, the pressure will be high and the ice cubes will start to melt. But when you remove the force, that means when you remove the force means the pressure will be again decreased. So it will again change it to ice. Okay. And also walking on snow is difficult because of this pressure effect. Okay, which lowers the melting point of ice. Okay. And also in the skating case, ice skating and like these cases also these problems are coming. When the ice skaters moves, their entire weight is supported by the thin plates of the skates. Yeah? So the area of contact of the thin plates with the ice is only a small fraction of the area of the blade. So the pressure exerted will be high. So what? The ice will start to melt. Okay. Then the layer of water formed enables the skates to glide easily. Why? The melting point of ice is lowered by an increasing pressure. Okay. Next is boiling and condensation. Boiling is a change of state from a liquid into a vapor. Okay, occurring at a constant temperature called the boiling point. So the process of changing liquid into gas at boiling point, that's known as boiling. Okay. So during boiling the temperature remains constant. That means the boiling point will remain same. If you want to keep the boiling, you must supply the heat energy continuously. But the temperature will remains the same. That will be 100 degree only. So during boiling the temperature remains constant at its boiling point. Okay. Heat is being absorbed by the substance. Okay. Then different substances have different boiling points. Yeah, in case of water, boiling point is 100 degrees Celsius, but in case of mercury, it is 357 degrees Celsius. But in case of hydrogen, minus 253 degrees Celsius. But in case of oxygen, it's minus 183. And alcohol case, you know already, that is 79 degrees Celsius. Okay. This alcohol and mercury boiling point we already discussed in the types of thermometer over there. The others are the new one. We need to learn this other substance boiling point. I just mentioned. Then next one, condensation. What is condensation? It's the reverse of boiling. That means our condensation, in case of condensation, the steam will change to liquid. That means the gas will change to liquid. So condensation is the process at which vapor changes into liquid at the same constant temperature. Heat is given out during condensation. So boiling case, what will happen? Heat is absorbed by the substance. But in case of condensation, heat is given out. That's only the difference. So for what purpose they are using this temperature? They are using this heat energy for breaking the bonds between the molecules. Okay, and to change the state from one form to another form. Okay. Next topic is effect of impurities on the boiling point of water. Impurities will increase the boiling point of water. Okay, that means like if you take one pan full of fresh water and another pan like salty water or like whatever you want you can add and check. Put it above the gas stove and switch on the flame, and you can see the fresh water will boil fastly than the salty water. That means the impurities will increase the boiling point of water. Okay, so that is what fresh water will take less time than the salty water. Even you are making tea, you can check these things if you are adding sugar and everything before putting the water into the stove, and so it will take a long time to boil. But if you are boiling the fresh water, it will take very less time. That means the boiling point of fresh water is 100 degrees Celsius, but the amount of impurity will increase, so the boiling point of the water or the substance also will increase. Then like effect of pressure on the boiling point of water. Reduced pressure lower the boiling point, and increased pressure raised the boiling point. Okay, so let us check each one. Okay, like boiling under reduced pressure. Okay, reduced pressure case means you can like maybe if you are taking like a egg or something, like give one of the example to you. Cooking times can be reduced by using a pressure cooker, whereas cooking an egg in boiling water on a high mountain top takes a very long time. Why like this? Okay, so let us check. So on a mountain top, actually the air is less dense, and so the pressure is lower. That means less pressure. So when compared to sea level, the pressure is low. Okay, that only. So water boils at the lower temperature. So that's what this happened. Then like boiling under reduced pressure has an advantage using less energy to get rid of excess or unwanted water, such as in the production of evaporated milk and granulated sugar crystals. Okay, and also next one is boiling under increased pressure. That means increased pressure will raise the boiling point. In case of pressure cooker only, like a pressure cooker is normally used to reduce the cooking time here. So in pressure cooker, the boiling point of water is raised to 120 degrees Celsius by increasing the air pressure in the cooker to about 2 atmosphere. So this is high temperature. That is what in high temperature explains why food such as vegetables can be cooked very quickly in a pressure cooker. Okay. So what are the properties of boiling? We already learned the difference between boiling and evaporation. So you must know that, okay, because that is very important in case of IGCSE. And boiling case, boiling is a quick process and it occurs at a fixed temperature. And it takes place within the liquid. Bubbles are formed in the liquid and temperature remains constant during boiling. Okay, heat supplied by an energy source. And evaporation case, already we discussed, then also occurs at any temperature. It's a slow process, takes place only on the surface of the liquid. No bubbles are formed in the liquid. Temperature may change. Heat supplied by the surroundings. Okay, so revise the topic again, whatever I explained that time, use that and learn. Next one is latent heat. What is latent heat? The amount of heat energy supplied to change the state from solid to liquid or liquid to gas at constant temperature is known as latent heat. Okay, SI unit of latent heat is joule. That means latent heat means that is a form of energy only, the amount of heat energy supplied. So energy SI unit is what? Joule. So same like that, latent heat SI unit is also joule. Okay, and it is represented by using the letter capital L. Okay, specific latent heat of fusion. Latent heat is divided into two: specific latent heat of fusion and latent heat of vaporization. Okay, latent heat of fusion means the amount of heat energy supplied to change the state from solid to liquid at constant temperature. But latent heat of vaporization means that is the amount of heat energy supplied to change the state from liquid to gas at constant temperature. Okay, so latent heat is divided into two, latent heat of fusion and latent heat of vaporization. Latent heat of fusion case, the change is from solid to liquid. Latent heat of vaporization case, the change is from liquid to gas only. Both case unit is joule only. Here, next topic is specific latent heat of fusion. You know already what's the difference between latent heat of fusion and specific latent heat of fusion. There is no difference, only over here specific latent heat case it mentioned the amount of substance. That's it. So the amount of heat energy needed per kilogram. See, per kilogram, that is only the difference between latent heat of fusion and specific latent heat of fusion. Okay, specific latent heat of fusion case we are mentioned the amount of substance. So the amount of heat energy needed per kilogram to change a material from solid to liquid at constant temperature. Its SI unit is joule per kilogram. Okay, and symbolically you can represent this equation LF equal to capital LF equal to small LF into M. Okay, capital LF is the latent heat of fusion. Okay, small LF is the specific latent heat of fusion. M is the mass of the solid. Okay, so if you want you can write this equation in terms of specific latent heat of fusion. So you can write it small LF equal to capital LF divided by M. Okay, otherwise specific latent heat of fusion equal to energy divided by mass. Energy means what energy over here? Latent heat of fusion. Energy supplied for that. Okay. Next topic is specific latent heat of vaporization. So specific latent heat of vaporization means that is the amount of heat energy needed to change a material from liquid to gas at constant temperature. But over here specific latent heat of vaporization. Specific latent heat of vaporization means that is the amount of heat energy needed per kilogram, okay, to change a material from liquid to gas at constant temperature. SI unit of specific latent heat of vaporization is joule per kilogram. Okay, and you can write the equation latent heat of vaporization LV, capital LV equal to small lv into m. Here small lv represents the specific latent heat of vaporization and m is the mass of the liquid. If you want to rearrange the equation for find out the specific latent heat of vaporization, the equation will be small lv equal to capital LV divided by m. Okay, specific latent heat of vaporization or specific latent heat equal to energy supplied divided by mass. This equation is common for everything. That means if the question is given to you specific latent heat of fusion, you can write like that specific latent heat equal to energy supplied divided by mass. So that time the energy will be latent heat of fusion divided by mass. That's all. That's also a specific, that may be like a latent heat of vaporization or fusion, whatever, that is the energy value only. Name only the difference. Okay. This is an experiment used to measure the specific latent heat of fusion of ice. See, look at the circuit arrangement. Do the connections as shown in figure. Okay. Like you can see the crushed ice in the conical flask, and lagging also. Lagging is used to reduce the heat energy leakage to its surroundings. And one of the immersion heater is fitted in between the ice cubes, and immersion heater is connected to the joule meter, and joule meter to the power supply. So whenever you switch on the power supply, the joule meter will show the value of thermal energy, and the heater will heats up. Whenever the heater will heats up, the ice cubes will start to melt, and it will collect the water, or the melted ice will collect in the flask. Okay. So what are the values are taken from this, and how will you calculate the specific latent heat of fusion? So first of all, you must measure the mass of the melted ice from the funnel and record the joule meter reading of the energy supplied by the immersion heater. Okay. Use these results to calculate the specific latent heat of fusion. Substitute these values in the equation. Specific latent heat of fusion equal to energy supplied divided by mass of ice melted. Energy value you will get from the joule meter reading. Okay. Joule meter reading is the energy supplied, that value. Okay. And the mass of the melted ice. Okay. How will you find out? First of all, like mass of the beaker you must find out. Before starting the experiment, you must find out the mass of the beaker. Then mass of the beaker and melted ice. Okay. And so mass of the ice melted by immersion heater, you just subtract these values. That means mass of the ice melted equal to mass of the beaker and melted ice minus mass of the beaker. So you will get the value of mass of ice melted. I hope you understood. Yeah, if you have any doubt, ask. This is very important. It's repeated in the past paper more times. You must know the diagram, how to draw and label, also the working and what are the values taken from this, and the formula also. Okay. Next is the experiment used to measure the specific latent heat of vaporization of steam. See, look at the connection diagram. Okay, ammeter is there, voltmeter is there, heater is there. Lagging, always lagging is also one of the important thing. It's used to prevent the heat energy to its surroundings. Okay, and how will you do the experiment? First of all, find the mass of water in the beaker. How will you find out the mass of the water? First of all, measure the find out the mass of the empty flask, empty vessel. Okay. After that, add the water into that. Then now you got the mass of the water with the flask. Then subtract these two readings, so you will get the mass of water alone. Okay. And then after that, after find out the mass of the water in the beaker, put the arrange the connections like this way, and switch on the heater. Allow the steam to escape when the water boils. That's what, there is no lid over there. Okay, if you are keeping the lid on, you can get the exact value. But for the experimental purpose, we are allowing the heat energy to escape, okay, like that way. But surroundings, we are not doing like this. So switch on the heater, allow the steam to escape when the water boils. Then start the clock when the water just begins to boil. Note the ammeter reading and the voltmeter reading. After 10 to 20 percentage of water has boiled off, switch off the heater and cover the beaker with a lid. Okay. Stop the clock and record the time of heating. Okay. Find the mass of water left in the beaker. Whatever you did before that process, again repeat and find out the mass of the water left in the beaker. Okay. Then you will get what specific latent heat you can calculate. After that, specific latent heat of vaporization by use of steam by using this equation, energy supplied divided by mass of water vaporized. Energy supplied means that's equal to, that is the product of current value into voltage value into time. Okay, I represents electric current value, V represent voltage, T represent time. So if you are multiplying these three quantities, you will get, that is the energy supplied values, divided by mass of water vaporized. Mass of water vaporized means, that is you find out initial mass of the water, okay, and M1 represents the initial mass of the water and M2 represents the final mass. So if you are subtracting the final mass of water from initial mass of water, so you will get the mass of water vaporized. Okay, this is the electrical method to find the specific latent heat of vaporization of steam. So learn the connection diagram, equation, everything. It's important. The next method is an experiment used to measure the specific latent heat of vaporization of water. Okay, so first of all, measure the mass of water and its container before and after the experiment. Okay, bring the water to the boil before starting the joule meter. Okay, record the joule meter reading of the energy supplied during boiling. Okay, use these results to calculate the specific latent heat of vaporization, equal to energy supplied divided by mass of water vaporized. So mass of water vaporized means initial mass of water and container minus final mass of water and container. So you will get the mass of vaporized water. So what are the readings taken from this experiment? Initial mass of water and container, final mass of water and container, then joule meter reading. These three readings you are recorded from this experiment. Okay, and you are using this value for calculating specific latent heat of vaporization. This lagging is used to prevent the heat energy leakage to its surroundings. Okay. I hope you understood the topic. If you have any doubt, please ask. Okay. And try to solve the questions in the chapter. Okay. Inside the book, and check the answers from the back of the book. And if any problem, please ask to me. Okay. Next physics class we will solve the end of chapter questions. Okay. I hope you are understood the topic. If any doubt, please ask. Okay, and learn these. All these are very important, and especially the diagrams and what are the values taken from these things, and also the equations. Okay, learn nicely. Okay.